Hi there, this is exercise 8B.2. I'm going to basically carry on straight from where I left off earlier on. I think I said there were two examples, and I've just looked and there are two more examples to go. So here's the first one, functions which require two Maclaurin expansions. And now on the face of it, that sounds like ones we've already done. But this is where it involves functions of functions. So I suppose my title is not overly clear. And you can see that here where I do it. The actual function, it says f of x equals, and it's the log of cos of x. So normally log is our 1 plus x. So I suppose the trick is to try to rewrite cos first as that, and once I've got that I can then sub it into this Maclaurin expansion. So I've done both these forms already. I'm actually going to start with the cos. I suppose functions are functions. We always did work backwards, so it's no surprise there. So cos of x, it's giving me the formula. And it says up to the x4 term, so I'm going to write cos of x equals, well, 1 minus x squared over 2 plus x to the 4 over 24, I suppose, 4 factorial. So this is my cos of formula, and you'll notice it's a 1 plus something. Well, it's 1 minus this and plus this. But I can think of this as 1 plus a minus x squared over 2 plus x to the 4 over 24, which isn't very nice, but you know, it definitely works. So when I come to do this log of cos x, really I'm doing the log of 1 plus this thing, this bracket, this rather horrible bracket. But it does mean I've got something I can now substitute into my log formula. And I've got to be a little bit careful. How many terms am I going to do? It might become obvious. Temptation is to say go up to the 4, but I might not have to go that far. So anyway, when you do this, it's x minus this plus this. So my x now, this bracket is really my x as in what this thinks it's my x. So it's going to become minus x squared over 2 plus x to the 4 over 24. There's my x. And I've got to write all of that squared plus x to the 4 over 24 squared over 2. And this is why I didn't think I'd need too many terms, because if I cube these things, that will be to the power 6, that will be to the power 12, and so straight away I'm over x to the 4. I'm already over x to the 4 actually, if you think about it, when I get that one squared. But certainly I don't need any more. So this will give me minus x squared over 2 plus x to the 4 over 24. And when I multiply this out, well, this times by itself will give me x to the 4. No, it's a minus this answer, so I'm going to write minus x to the 4 over 4 on the square. But then I've then got to divide by 2, and I reckon over 8. And all the other terms, that times by that will give me x to the 6. That times by itself will give me x to the 8. Yeah, so I think that's me done. So when I multiply this out, I think I get that. So this gives me minus x squared over 2. Well, this is like 3/24, which I'm taking away from 1/24, which is minus 2/24, which I reckon is 1/12. It doesn't mention validity. Let's see if that's the answer. Minus a half x squared minus a 12x to the 4. I think that's what I had. Yes, it is. So that worked quite nicely, but it was just making the cos into the 1 plus form, because once I've got the 1 plus form, I can then do the log. I've got another example here, and again it uses e to the x and cos this time. Last time it was log of x and cos, so I've got both formulas here. And it's find e to the cos x. Now, e to the cos x doesn't require any special things, but it does tell me a little trick here. You may need to eventually split the exponential term using this trick. So let's try and do that and just bear that trick in mind. So I've got to do the cos first, so it's e to the something, isn't it? It's going to be e to the cos x. Now what is cos x? It's that thing there. It's 1 minus x squared over 2 plus x to the 4 over 24. And of course, it's not very nice, but the nice thing is I can split this into e to the 1 times by e to the minus x squared over 2. I suppose this is, you could try to do it all in one bash, I suspect, here, because it doesn't say it has anything special in the x, but I think it'd be easier to do it like this. And when I do it like this, e to the 1 is just e, I can do that. But then I just do this as the Maclaurin expansion using this formula. If I do this, my x effectively has become, what is it, minus x squared over 2. That's what I've got to sub in there. So this one will give me 1 plus minus x squared over 2. And it says, that's it, yeah, plus this minus x squared over 2 squared over 2 factorial. So that, I think, is this bit here done, you know. But of course I've got this other one to times it by. And now my x becomes, what's become? It becomes a positive x to the 4 over 24. That's what I'm going to sub in this time. So this gives me 1 plus x to the 4 over 24. And then, well, again, theoretically there's another one here, but as soon as I raise that x to the 4 squared it, I'm going to get x to the 8, so I'm not even bothering to write it. So what's this give me? It gives me e times 1 minus x squared over 2. It's definitely a plus x to the 4 over 8 times by, let's get my pen back, times by the 1 plus x to the 4 over 24. So I don't want you to multiply all these terms out. I want you to say to yourself which ones will give me an answer which doesn't break the x to the 4 rule as a maximum power. So obviously the 1 times by both of them work. 1 plus x to the 4 over 24. Oops, didn't mean that. Now the x squared over 2 times by the 1 will give me a term. But also the x to the 4 over 8 times by the 1 will give me a term. And so therefore I've got an answer which is e, and what's that, in brackets I'm going to get 1 minus the x squared over 2, and here I've got 3 24ths plus 1 24th is 4 24ths is plus a 6th, x to the 4 over 6. That should be my answer. E1 minus x squared over 2 plus a 6th of x to the 4. So that works as well. So again, it's just a function of a function, and our trick was to work out what the cos x can be written as, which then subbed it back in, and then we had the this bit here where we had to split it into 3 different parts, and then do 2 of them as Maclaurin expansions, but then just have the e at the front as well, which is fine. So that's basically it. We've finished the second part, and I want you now to do exercise 8B. It's either on page 178 or obviously on the sheet if you've been given the sheet. And the formulae are there. I suggest you write those down carefully in your books, because you will need all of those at some point. And of course you will be given them in the formula book on the day, but you're going to use them lots and lots, including on your homeworks. So good luck on those. I hope they kind of make sense.